In last lecture, we studied different application lifecycle states. We discussed what happens when application starts, and we also discussed what happens when an application is paused. We will continue our lecture from that, and now we will see what happens when application moves to different other states. So let's start with resuming an activity. So when we resume an activity, onResume is called when a user resumes an activity from the paused state. OnResume is called every time your activity comes into the foreground, including when it is created for the first time. As you saw in the diagram, and let me go back to it again. So OnResume is called from the paused as well as from the started state. When you implement OnResume, you must initialize the components that you release during onPause. So if you release some components when your application went to pause, you must reinitialize them, as you can understand. You can also use onResume to perform any other initialization that must occur each time the activity enters the resumed state. Now let's move on to the other two states, that is stopping and restarting an activity. As you may have seen with your use of Android applications and Android phone, that an application may stop in different scenarios. For example, from time to time, you switch between one application and another. That is, you go through all your recent apps windows and you choose one application over the another application. In this case, the activity in your app that is currently in the foreground is stopped, and if you return to your app from the home screen launcher icon or the recent apps window, the activity restarts. So many times we do that we press our active application list and we start working on the same application where we were working before. Similarly, if an application starts a new activity in your application. Similarly, if a user performs an action in your app that starts a new activity. The current activity is stopped when the second activity is created. If the user then presses the back button, the first activity is started. The user receives a phone call while using your app on his or her phone. In this case, the phone application starts, your activity of your application stops, and when you go back, your activity on your application starts again. We use the methods onStop and onRestart to handle the situations that arise because of this stopping of an application or restarting of an application. Let us first see stopping an activity. So once onStop is called, the activity should release almost all resources that are not needed while the user is not using it. This is an essential step because onStop is just one step above onDestroy, that is the destroy method. So whenever onStop is called, you must safely assume that user may simply be leaving your application and your application may need to be destroyed, which means that you must release almost all resources that the user has been using. And once an activity is stopped, the system actually might destroy the instance if it needs to recover some system memory. That is, maybe your application or activity does not want to be destroyed. You wanted to keep it open, but your activity reached into the stopped state, and suddenly, because of some other application, the system requires more memory. In this case, the system will kill applications which are in stopped state, and that may be your application. How the system restores such applications, we will study very soon. In some cases, system may simply kill the application process without even calling onDestroy method. All this indicates to our first point, that is, whenever the onStop is called, you should try to release all the resources that you have been holding. When an activity is stopped, the activity object is kept resident in memory and is recalled when the activity resumes. There is no need to reinitialize elements that were created during any of the callback methods leading up to the resumed state. Please pay attention here. I am saying components that were created during any of the callback methods leading up to the resumed state. I'm not talking about after that. The system also keeps track of the current state for each view in the layout. The views were different views objects like buttons, edit text, radio button, etc. So if a user has entered a text into your edit text widget, then that content is retained. You need not to worry about it. On restart is called when activity comes back to the foreground from the stopped state. Let us see the diagram. Here you see on restart is being called when activity comes to the start state from the stopped. And as you will see also that after on restart, on start is called. So on start can be used to perform some restoration work that might be necessary only if the activity was previously stopped but not destroyed. And on start will be called every time an activity becomes visible, which means that if your activity is only going from a visible mode to hidden mode to visible mode, on start method will be called every time. While on restart will be called only when the activity went into the stopped state. Please try to understand the difference in which these two methods are called. Let us see through the diagram. So you see that on start is being called even in the beginning because your application has to become visible, while there is no on restart. But on restart is called when an application is stopped, and after that it will call on start to make it visible. Now let us look at recreating an activity. Just some time back I told you the scenarios in which an application can be stopped. Now let us see when an application can be destroyed due to normal app behavior. For example, you may press the back button to destroy your application. Your application itself may signal its own destruction by calling finish, that is, your application ends. This is similar to any other program that you have written in Java that ends after some time of execution. These are the scenarios which are considered the normal app behavior. However, the system may also destroy an activity if it is currently in the stopped state and it has not been used in a long time, and the foreground activity requires more resources. Whenever you are running multiple applications on Android, and if the Android system feels that the application which is running requires more resources, it may kill any activity that is currently in the stopped state and has not been used for a long time. However, because it is the Android system which is killing the application, before destroying the application, it creates a new instance in case the user comes back to that application. And this new instance is used when the user tries to come back by pressing the back button. The data which is saved to create this new instance is often called instance state, which is nothing but a key value pair stored in a bundle object. You may remember bundle object from the parameter that we passed in the onCreate function. Let me show it to you one more time. I will run my Android Studio. We will go back to our program where we will see the bundle object. Again, I am using a simpler version of the program, not the version that we just created in last week's classes. Yes. As you see in the onCreate, we are passing a bundle. This is the bundle that we are talking about. The bundle is nothing but an object of type class bundle. If I click, I go and I see yes. Final class bundle extends base bundle, implements cloneable. So saved instance state is the object of the type class bundle. The activity is destroyed and restarted each time the user rotates the screen. We saw that in last week's lecture. That when we rotated the screen, all the question order was reset. Now by default, the system uses the bundle instance state to save information about each view object automatically. That is, system is handling for all the view objects that you are using. Anything more than the view object, you have to handle yourself. So suppose if we were displaying multiple questions 1, 2, 3, 4, which are being monitored by progress of the index in the array, the integer variable that I am using for the array needs to be maintained by me as a developer, while the view objects, that is the buttons, the text, edit text, text view fields, they will be maintained by the system. So all the other state information, for example member variables, need to be saved by the app, by you. You will have to code for it. How do you do that? You override the onSaveInstance state callback method. The system calls this method when the user is leaving your activity and passes it the bundle object that will be saved in the event that your activity is destroyed unexpectedly. If the system must create the activity instance later, it passes the same bundle objects to both the onRestore instance state and onCreate methods. Let us see this in a simple diagram. From destroy, onSaveInstance state method is called, application resumed. From resumed, onRestore instance state is called and application is created. Here I am giving you a simple program sample that shows you how to store values in the bundle in form of a key value pair. For example, I want to store the values of state score and state label. I go into the method, I have overridden it, the override you see. In that method, I use saved instance state dot putInt state score mCurrent score. So mCurrent score here is my variable that holds the current value of the score, and these values are now stored. In next slide, I will see how to restore from these values. So restoring your activity state. You can recover your saved state from the bundle that the system passes to your activity. Both the onCreate and onRestore instance state callback methods receive the same bundle that contains the instance state information. OnCreate method is called whether the system is creating a new instance of your activity or recreating a previous one. Because it can be called in both instances, you must check whether the state bundle is null before you try to read it. So let us see a sample program code on how to do it. So in the onCreate, we want to check that whether there is any useful value in the saved instance state or not. First we check it for null, and then we restore our values which earlier we stored. Here we stored them in mCurrent score, mCurrent label. Here we restored. The another way of restoring is to implement the onRestore instance state. This is a method which the system calls after the onStart method. A good point about this method is that system calls it only if there is a saved state to restore, which means that there is no need to check whether the bundle is null. So in case we take this route, we will define the method and we will directly restore it without checking for null or anything. For this lecture, I have been using the reference from developer.android.com. You can go to this website and find out information that I am using in this lecture. Now let us go to our program and try to see some of these things. This is our onCreate method, and this is our saved instance state. This is our manifest file, which is telling that my quiz activity is the main activity. This is the Java file that defines the quiz activity. If I run my program, it will take a while because we are starting the emulator. I am hoping that now you have started programming on Android Studio. If you have not, then please start. Without writing your own programs, you will not learn Android programming. Let us wait till the application is launched on our emulator. Yes, so as you see, it is a simplified version of our quiz app. Press true, I press false, nothing happens. Let me rotate my phone. Now when I rotated this phone, you cannot see a change, but if we had moved to another question, it would have been restarted from the very beginning. Because every time to rotate your screen, your application goes through the complete cycle. And because we are not implementing nor storing anything in saved instance state, I will lose the value that I may need in order to maintain current question count. That is it for this lecture. In the next lecture, we will learn how to do logging in Android. Logging is a very important feature both to do debugging as well as to understand the behavior of an application. Thank you.